Chapter 10 is about geometric symmetry and the golden ratio. To understand what symmetry is about, we have to talk about some concepts beforehand. So the very first section talks about transformations using rigid motions. A rigid motion is when you're going to move one object from one location to another location without changing its size or shape. So in other words, if you drew a triangle, let's say you drew a triangle here, you would then move that triangle over to some other spot, and the triangle would stay the exact same shape as the triangle. We call the original shape and the move shape are what we call congruent because they're the same size and shape, they're just not necessarily in the same exact location. There's such a thing called an identity matrix motion. An identity motion is where you do a rigid motion to an object, but it doesn't look like it moved at all. So if you took an object and you rotated it, and then that object looked exactly like it was before, it would have an identity motion. So let's talk about what the four rigid motions are. There's a translation, which is moving. There's a rotation, which is to rotate something, turn it. There's a reflection or flipping it. And there's a glide reflection, which is a combination of translation and reflection together. So we're going to look at each one of these individually. Let's start off with a translation. A translation is to slide an object a certain direction for a certain distance. So in other words, you might start the object right here, and you might move it along what we call a vector in a certain direction, and it ends up over here. And you went that very certain distance. So you can kind of think of this as if you move a chair across your room. The chair didn't move other than moving where it was. It didn't change shape. It didn't do anything different. It just moved from that one location to another location in your space. Another example of that would be, let's say I took this shape here, this pentagon, and I picked it up and I slid it along this vector. So this point here, right there, we're going to call it point A. We picked that point up and we moved it along this vector to that point. We're going to call it A prime because it relates to A. It just isn't a new location. And everything, the whole thing, then has to move because you can't change the shape. Another example is that B here, that point B, becomes this point B prime. Again, it moved on that same vector. That length is exactly the same, and the direction is exactly the same. Another location idea is that you can move from this point here A to this point here A prime, and everything just kind of moves. So if I were to have a heart here, I could move that heart here and take it over to here. So translations are just movements in a very specific direction. Let's talk about rotation. Rotation is to pivot an object around a fixed point called the rotocenter. It's kind of like turning it. Some examples of a rotation are I could have a triangle here. Here's my triangle, ABC is my triangle. And I might have my rotocenter way over here. And what I'm going to do is I'm going to take this line here, I'm going to rotate it into this line here. And so notice the rectangle doesn't look exactly the same because it looks at a different point of direction because it rotated it. But it's the same shape, the same size as it was before. This point A is now over here. We call it A prime. This point B is in this location. We'll call it B prime. And this point C is called C prime. This rotocenter is outside the object. You can kind of think of it as you took a piece of paper and you moved it, you rotated it around a different point. You can also have the rotocenter and the center, or in the object. So let's say it was here, and I rotated about that point. So I kind of thought of putting my finger down and rotating that triangle, and it might end up looking like this, depending on how many angles you go through to rotate it. Here's another object. Again, my rotocenter's in it. I just took it. It looks like I rotated it 90 degrees clockwise. This one, again, I'm going to rotate it. Let's say I rotated this 360 degrees. So it looks exactly like it started with. So that would be my identity matrix. Identity motion. It turned exactly as it was. It looks exactly like it was as it started. Again, here's another example where the rotocenter is outside of it. So this object here rotates along this line now, rotates over to this area, and then your arrow looks like a new arrow here. The thing to notice is that this is not identity matrix because identity motion, because this object here obviously does not look exactly the same as this object here. All right, so the next type of rigid motion we're going to look at is called a reflection. And this is where we're going to flip an object over an axis of reflection. Think of this as you're staring at yourself in the mirror and how things look in that mirror, or think of dividing yourself in half and what it would look like. So some examples of this is I could have a triangle here. We like to use geometric shapes, it helps us. And then we've got this axis here, so we're going to flip over this axis. So this point C, which is this distance from the axis, is now going to come over here to C prime, which is the same exact distance here as it was here, just on the other side of the line. So you'd find out what this distance is between the line and C, and you'd draw the exact same distance from C prime to the line. And that would tell you where C prime ends up. Same thing with B. This distance from B to the line is the same as the distance from the line to B prime, the same for A. So that's one way to actually draw reflections, is to go ahead and notice that this point A from here to here, find that distance, then go directly from that to over here on the other side of the line to get your A prime, and then you can draw your triangle. Your axis of reflection could be inside the object. So notice here again is A, B, C. My axis of reflection is through the object, and I rotate everything about it. Again, this point, this distance from A to the line, is the same as this distance from A prime to the line. So to draw it, you just find out what this distance is, go directly across the line, the same distance to get A prime. Same thing with from B to the line, and then the line to B prime, and the same distance as from C to the line, and then the line to C prime. We can have lots of different axes of symmetries that you can work with. So if we had an axis of symmetry that came down to the line here and flipped it, notice it actually looks just like itself when it got flipped. This is an axis of symmetry goes this way. We're basically flipping it upside down. So this point A suddenly is down here to A prime. And B went up here to B prime, and C went from here up to C prime. We can do lots of different shapes. Think about what would happen if you reflected it along this line for this star, and you can see what it would look like. Think in your mind what it might look like. Do the same thing with this arrow. Neither one of these are identity motions because the object would not look exactly like itself when you reflected it. And then the last one is a glide reflection. This is where you're going to move the object through a translation, and then you're going to reflect it. You can also, by the way, do the reflection first and then the translation. It really is up to you. The axis of reflection is parallel to the vector, so you wouldn't move it one way and then rotate a totally different location. Or not rotate, but reflect. So here is an example. Let's say we take this triangle ABC. Here's my axis of reflection. So I'm going to reflect ABC across this line. Again, you can do it in any order you want. So I'm going to reflect first. So B, let's call it B star this time. C to C star, same exact distance again. And A to A star, same exact distance. Think of it, you're drawing a line from A to A prime, and that line should be perpendicular to your axis of reflection. Now that we have that, we're also going to have this vector that's going to move these points over. So they're going to move from here all the way over to C prime. So C star starts here, moves along this vector, and ends up in C prime. B is going to go the exact same direction, the same length, and it ends up at B prime. A is going to go the exact same direction, same length, and it ends up here at A prime. Notice that vector is in fact parallel to your axis of reflection. And that's those different types of translations. So think of trying one on your own. Let's say I want to reflect this about this line and then translate where it's going to end up. So it's going to flip over the line and then it's going to move over to here. So think of all those locations and what they would look like. And that is rigid motions.